Special Topics in ICT Advanced Machine Learning কোর্সের লেকচার 11 সবাইকে আমন্ত্রণ জানাচ্ছি। Today's topic is recommender system, and recommender system is basically predicting some unknown value. Say for example, in different movie site there are different rating for different by the different user. For certain movie, a user after watching the movie is requested to rate the movie according to his likeness. And based on this previous recommendation, the movie, whether it is suitable for a new user or depending on his previous watching history, the website itself suggests certain movies for maybe for his likeliness. So this is called recommender system. A recommender system is nothing but providing some recommendation, advanced recommendation for certain particular task. Let us take an example. Predicting movie rating. Let us say in a movie store or in a movie site, there are 5 number of movie: Love at Last, Romance Forever, Cute Puppies of Love, Non-Stop Car Chases, Swords versus Carrot. And let us assume that there are 5 users: Alice, Bob, Carol, Dave, A, B, C, D, or 1, 2, 3, 4 user, and they have been requested to rate the movie from 0 to 5. Although the star is from 1 to 5, but they can put 0 if they don't like a movie. So let us say Alice rated this first movie, which is Love at Last, with 5 stars. It indicates that he or she liked it very much, that's why he gave full rating. For Romance Forever, he gave the similar rating, same rating actually. And next movie, Cute Pupils of Love, he didn't watch that movie, so he didn't submit any rating. For Non-Stop Car Chase, he put 0, and Sword versus Carrot, he also put 0. That means she didn't like these 2 movies. Similarly, Bob, Carol, and Dave, they also rate the movie, and some of the movies they didn't watch. That's why they put question mark. So this question mark indicates that he didn't rate the movie. Otherwise, in other words, he didn't actually watch that movie. So our first job may be we may be able to predict their rating, which is they didn't put any rating. So how to predict movie rating? By looking into the other rating of the other movies. So let us talk about two, actually 4 abbreviation or 4 level. One is NU, other is NM, other is RIJ and YIJ. NU is the number of users. That means in our case, NU is 4. NM is the number of movies. In our case, it is 5. Rij equal to 1 if user J has rated movie I. So movie number is indicated by I and user number is indicated with J. So if a particular user J didn't rate a movie, we will call Rij equal to 0. Or if he has rated a movie, we call Rij equal to 1, and Yij is the actual value that he has given for a certain movie or rating he has given for certain movie. That means Yij is the rating given by the user J to movie I, defined only if Rij equal to 1. If Rij equal to 1, we will not define Y. So Y will not exist at all if Rij equal to 1. So N equal to 4 and Nm equal to 5. So next step will be how to find out the value or rating in the question marks. So we may see from the rating the from the name of the rating. Love at last, romantic forever, cute couples of love. Those are romantic movies. And the other movies, non-stop car chases or sword versus carrot, maybe action movie. And you can see the rating. The first group is rated in 4 and 5, in the order of 4 and 5. And in the second group, Alice and Bob rated them 0. On the other hand, you can see the Carol and Dave, they didn't like the romantic movie, rather, they liked the action movie. Now, let us talk about content based recommender system. Content based means when the other ratings are given, that means some of the ratings by some of the users are given for certain movies, then we can predict the other movies, other ratings actually, and that is called content based recommender system. So let us see the previous table where we showed the rating given by the different user, and question marks indicate that the user didn't put any rating. So number of user is 4 and number of movies is 5. So there are 5 movies: Love at Last, Romance Forever, Cute Puppies of Love, Non-Stop Car Chases, Swords versus Carrot. And from user point of view, there are 4 number of users: Alice, Bob, Carol, and Dave. So these are the 5 ratings that the user didn't put. So our job now will be to predict this rating. If they have watched the movie, particular movie, what could be the rating? Whether it is 4 or 3 or 2 or something else. So for that matter, we have to define the features for individual movies. That means the characteristics of individual movie. For example, the movie number 1, which is Love at Last, that can have 2 characteristics. That means it can be some sort of romance, some sort of action. So what degree the romance exists in that movie and what degree action exists in that movie. So that is called features of that particular movie. So let us assume that there are 2 features for each and every movie, and the degree of that features is defined in that table. So movie number 1, movie number 2, movie number 3, 4 and 5 all have got their feature x1 and x2. So if we add the intercept term x0, then the total number of features will be 3, x0, x1 and x2. And we can define the feature vector x1, this particular movie's feature vector, by this column matrix or vector 1, 0.9 and 0. So similarly, all the movies will have one feature vector x2, x3, x4 and x4 5, and the number of feature is 2, which is excluding the intercept term. That means the real features. So the feature vectors for different movie let us term as x2, x3, x4 and x5. Each x has got component features x1 and x2. Also x0 constant x0 equal to 1. So let us say x3, in order to determine this particular rating or predict this particular rating, let us first of all define x3, which is x0, x1 and x2. You see x3 1 is 0.99 and x3 2 is 0. So the vector will be 1, 0.9 and 0. So for each user j, learn a parameter theta j, which is the order of 3. Predict user j as rating of movie I with theta j t xi. So for particular movie, for example this one, we have to know the weights or the theta. That means your particular parameters of different your feature. Since there are three features, similarly there will be three parameters theta 0, theta 1, theta 2. But that is applicable for certain user. So user 1 has got theta 1, user 2 will have another parameter vector theta 2, user 3 theta 3 and user 4 will have theta 4. So to predict this particular rating, what we'll do, we'll first of all calculate or we form the matrix or vector called x3, which is 1.9 and 0, and we have to find out theta 1 because this is for first user. Let us say we will follow certain algorithm to find the theta 1, and after solving that algorithm we found the theta 1 to be 0, 5 and 0. We'll discuss how to find out this theta j for certain user, and if this is the values, then the particular prediction will be theta j transpose multiplied by x, and this comes from your linear regression. The linear regression also, if you want to find out the predict the certain output, you follow this formula. So in this case, theta 1 transpose, that means for the first user, theta 1 transpose multiplied by the third movie means x3, the features of x3. So if I transpose this matrix and multiply with this matrix, then it will be 5 multiplied by 0.99, which is equal to 4.95, which is very close to 5. And this is understandable because this particular movie falls into the group of romantic movie. That's why the prediction is correct. And the correctness depends on the how did you find out this theta j or theta 1 in this case. But we'll talk about later in later slides how to find out the theta j. So if this is the case, our next discussion will be how to find out the parameters for certain user. That means parameter vector for certain user. So problem formulation is Rij equal to 1 if user j has rated movie I, otherwise 0, and Yij is the actual rating given by the user j on movie I if defined. That means if he has rated, then only will define Yij, otherwise Yij is non-existent. Theta j is the parameter vector for user j and xi is the feature vector for movie I. For user j, movie I, predicted rating is theta j transpose multiplied by xi, which comes from the linear regression. So let us, for the time being, define another symbol, which is mj. mj indicates number of movies rated by user j. For example, the first user, Alice, he has rated 4 movies. That's why mj will be equal to 4. Now the problem is how to learn theta j. And as we know from our previous knowledge, the technique is called the minimization of the cost function, the objective function. And in this case, theta j has a order of n plus 1. So what is the objective function? As we know, the objective function is minimization of theta j, 1 over mj, number of prediction that is made. I exist only for when Ri is equal to 1. That means those terms will be added if Ri equal to 1. The movies that he has not or she has not rated will not include that term. So if you sum all the terms which has got certain rating, then the objective total error or total cost function is theta j transpose xj, that is the predicted value minus actual value whole square. That means error for one movie, then in the second movie, third movie for certain user, and total is theta. Once we get the cost function, if I differentiate that with respect to theta, and then we can update theta j with certain learning rate. So next part is the part of the regularization term. So in order to regularize the term, that means in order to we correctly take into account the effect of higher order term, we use this term lambda divided by 2mj, k varies from 1 to n, theta k x theta I equal to 0. That means for certain it should be theta j, in fact theta j whole square. So this term is actually the regularization term. The regularization factor is lambda, and in this expression we can ignore this constant term mj, because since it's a cost function, it doesn't matter whether you divide the whole equation by mj or not, because we have to minimize this function or this equation, this value. So minimization with mj or without mj is same. So same theta j you can obtain by discarding this mj term. So in order to simplify the equation, we will do that. So the discussion that we made so far is to learn theta j or parameter for your j by minimizing this term. Again, the same error remains, it has to be j. Anyway, so this function or this particular equation, if you solve, then you will get the cost function for certain user. But if you want to include all users, that means error by all the user for all the movies, then the equation has to be extended by another summation term, which is j varying from 1 to nu. So j varying from 1 to nu, this I has to be replaced by j. So this j, if you vary from 1 to nu, then you can actually find out the total cost or total error. So you have to differentiate this error with respect to certain parameters of certain user. For example, theta k1 or theta k2, that means k is equal to, it can be 1, it can be 2, or it can be 0. We'll discuss that one. So this is actually only the definition of the objective function or optimization objective in order to find out the actual value of parameters theta. So from the previous slide, we got this equation again. So this equation, if I say this part is nothing but cost function, minimization of this cost function, j theta 1, theta 2 up to theta nu number of user. And if we follow the gradient descent update, then you have to differentiate the j theta with respect to theta. And for first term, that means k equal to 0, we don't include the regularization term. That's why this second equation, which is for k not equal to 0, you will have the regularization term. So this is the updating formula, and you should remember that you have to follow the simultaneous update. So k varying from 1 to n, you have to calculate the new thetas, and k equal to 0, you have to calculate the theta. So this is theta 0. So these two equations, if you update simultaneously, then you will get new theta until it converges. That's how you can get the theta or parameters for each and every user. Now let us discuss about collaborative filtering. And first of all, what is problem motivation for this topic? We have defined the different rating of different users for certain movies, and we also defined the two features of the each and every movies. One is romance, and another is action. And we have said that these values are given values. The one way of knowing these values is to ask the user, every users about the movie, and then you put their feedback in a number, and that could be the one way. But asking everybody for every movies is not feasible if the movie number of movies and number of users is high. So there is another technique that we'll discuss now. If the feature value is not known, for example, all are unknown, then how to find out these x1 and x2? The first step that you have to follow is to ask one user about his likeliness. After watching all the movies, he may say that he liked the romance in the movies and he didn't like the action in the movie. So you put for the first user the parameters as 0, 5, 0. 0 is for x0. So this is not actual feature. So first feature is the romance. Since he or she said that this is romance is the feature that is liked about the movies, and the action in the movies it or she didn't like. So the feature vector will be 0, 5, 0. So this one information you could collect from the user. So what feature he liked, either romance or action, just yes or no. Then you put 0, 5, 0. Similarly, theta 2 is the features that is liked by Bob, and he also liked the romance in the movies, all movies. But the user number 3 and user number 4 like the action in the movie. So you put the third value of the vector as 5. So the first feature is theta 1, and the first parameter vector is theta 1. Second parameter vector is theta 2, and third and fourth are theta 4 and theta 3 and theta 4. So these are the thetas that you have to collect from the users and set as a initial value. So this common name is theta j. So you can proceed with theta j, these thetas, to find out x1 and x2. Once theta 1, theta 2, theta 3, and theta 4 are set, then how to calculate x1 and x2? Since the ratings are known for different user, the same movie, the rating unknown. So if x0 equal to 1, then x1 and x2 should be 1 and 0, so that the rating for user number 1 and rating for user number 2 are satisfied. So the first movie, the characteristic or the features is x1 vector. So x1 vector is 1, 1, 0. So this vector, if I multiply with theta 1 transpose, that should give you the 5. Again, this vector multiplied by theta 2 transpose, then it should also be 5. But if you multiply theta 3 transpose with x1, that has to be 0, and theta 4 transpose multiplied by x1, and that has to be also 0. So this value satisfies 1 and 0. Value satisfies the all the rating that is provided. With the theta 1, we can easily verify these particular values. So now let us discuss about the optimization algorithm. So how to find out the value of x, different x, mathematically, not intuitively. So the problem is, the statement is given theta 1, theta nu, that means all the vectors. If you know, then how to learn xi? So to learn xi, you have to have the cost function, which has to be minimized over xi. The value of xi that minimizes this expression is the value of xi. So minimization or the objective function is theta j transpose multiplied by xi minus yij has to be squared, and that is the error square, and that the terms that we will take only where rij equal to 1, and also the regularization term. Since we are minimizing over xi, so all xi square has to be sum up together and multiplied by lambda by 2. So this is the statement for certain movie. But if you consider all the movies I equal to 1 to nm, the same cost function, that means the similar formula, introducing all the errors for all the movies, when you minimize over x1 to xm, that will be your cost function. And this cost function has to be differentiated and multiplied by learning rate, and then update x1 to xm. The similar to the theta, the statement that we have discussed the slide before the last one, the instead of theta now it is xi. So once theta 1 is given, you can calculate the x1, x2, x3, etc. Now what is collaborative filtering? Collaborative filtering is when the x1, xm are given, then estimate theta 1, theta n. That is the discussion that we discussed about 2 or 3 slides before. That means movie ratings are given, and x1 and x, all the features are given. Then you calculate, estimate theta 1 to theta 2. That means features estimation. And where Rj is known, Rj is equal to 1 when a rating is made, and Rj equal to 0 if there is no rating. And Yj is the actual, Yij is the actual value. So collaborative filtering actually means that once you get the theta, then you apply that theta to x to find out x, and once you find out the x, then you will find out the theta again, and so on until the theta values and x value converges. So following the previous discussion, let us formulate the optimization objective in case of collaborative filtering. As we have mentioned earlier, that given x1 up to xnm, estimate theta 1 up to theta nu. That means the feature vectors for each movie, if they are given, then the parameter vector for each user you can determine by minimizing this cost function, where j is varying from 1 to nu, and I take I only those which has got Rij equal to 1. And this is our regularization term. So since we are optimizing over theta, so this has to be summation of all the thetas in the range of j equal to 1 to nu and k equal to 1 to n. N is the number of features for certain vector. Similarly, in the next one, I optimize or determine x1 to xnm. So you have to minimize the cost function over x1 up to xnm, where I varies from 1 to number of movie, and j, take j where Rij equal to 1. And the regularization term is now the summation of all x over I equal to 1 to nm and k equal to 1 n, which is number of features. So in the last slide, we said that once you get the theta 1 up to theta n, apply that theta 1 to theta m in this equation and get new value of x1 and xm, and repeat these two equations one after another, and finally you stop where they converges. But you can actually have a combined equation without going one after another and repeat the two formulation one after another. You can have one single equation where the function will be from x1 to xnm and theta 1 to theta n. That means all the x's nm or xn, your theta, all are the variables in a single cost function. So you take the first terms as a combined term there. So the first terms are these two terms, and if you notice that the one in one case j is varying from 1 to nu, in other case I is varying from 1 to nm, and the other summation I take I all I where r ij equal to 1, and take all j where r ij equal to 1. So combining these two, you can have a combined summation which is ij all ij where rij equal to 1. That means all the predicted term and the given term for those where the rating are given. If the ratings are not given, then you will not take the stops. So this covers actually both the terms. That's why this is a common term. And the regulation term, you have to take both the regulation term, and this is the ij where r is equal to 1. So regulation term, this is one regulation term, this is the theta term, and other is x term. You take all the x terms. So simultaneously, you can have a single cost function. That means you have to differentiate this equation with respect to x1, x2, x3 up to nm, and also you can have differentiation of this term with respect to theta 1 up to theta nu. So with a single go, you can determine the updated value of all x's and all thetas. So let us discuss about the constant term. In the previous case, x0 was considered as 0, and we also considered theta 0. But in this case, you just ignore the x0 equal to 1, and also the dimension of x was n plus 1. Now the dimension will be only n because the number of x has reduced. And what happens in this case? In this case, the automatically the value will take up the x1 up to xn, and one of the x could be 1. After the optimization, it may be close to the 1. So it will be naturally constant value, but you don't have to force value 1 to one parameter for this objective function. If I summarize the collaborative filtering, the algorithm will be first of all initialize x and thetas to small random values, then minimize j, which is a function of x and thetas, and apply gradient descent or in advanced optimization example to determine the x and theta. When you are calculating x, you differentiate cost function with respect to x, and when you are updating theta, you differentiate the cost function, combined cost function with respect to theta. And there is no separate term for k equal to 0 and k equal to other than 0, because the k equal to 0 term is absent here. K varies from 1 to n, that's all. So the equations become simpler. And finally, for a user with parameter theta and a movie with learned feature x, the predict a star rating of theta tx. So similarly, previously the same thing theta j transpose multiplied by xi, the similar equation. If you want to find out all the predicted value, you just multiply the matrix theta, transpose it, and then matrix x. So that's actually concludes the collaborative filtering algorithm. In the last slide, we have described the algorithm for collaborative filtering. In a single go, we can find out the update of x and theta. X means the feature vector for certain movies, and theta is the parameters for certain user. So there is an alternative way of finding the different rating or missing rating actually, and that can be obtained individually by using the formula theta j transpose multiplied by xi, but the matrix implementation or vectorization way of finding that value. So this is the table that we have been showing for several slides. That means the rating given by the different user, the value of the rating, and also the missing rating. That means the places where the rating is not are not given. So first of all, you compose a matrix called y. Y is the values of all yij. That means the rating of a certain movie I by user j. So in this case, the number of users is 4 and number of movies is 5. So this is 5 by 4 matrix, and this is called capital Y matrix. With this capital Y matrix, you can find out the theta and x, as we have shown in the previous slides, that how to calculate or how to update the theta and x simultaneously. And after you obtain the theta and x, the each and every individual's question marks can be obtained by using the formula theta j transpose multiplied by xi. So each and every position of this matrix can be predicted by a predicted matrix. This is called predicted matrix, where you can see that each term is the same form of theta j transpose multiplied by xj, the number of user. In the column is the number of users you see, x1, theta 1, theta 2, theta nu. And in the number of rows, it is number of movie x1, x2 up to xnm. So each position is defined by ij. I is the movie index and j is the user index. So each of the element can be generalized by theta j transpose multiplied by xi. For example, the first element is the element for a movie number 1 and rated by the user number 1. So movie number 1 rated by the user number 2. Sorry, movie number 1 rated by the user number 1. Movie number 2. Similarly, this one is the movie number 1 but rated by the user number 2. So all the elements of this matrix, this one is the rating given by the user number 1 for movie number nm, that means last movie. So if you find out the correspondence between this matrix and that matrix, so this element is nothing but this element, and this element is nothing but this element, and so on. So once you get theta and x, this unknown element can be determined from this matrix. So this matrix, how to obtain this matrix? So first of all, you have to determine a capital X, which is the same as the formation that we have shown in the case of the linear regression, where X vector is transposed and form the row of this capital X matrix. So X1 transpose, X2 transpose up to Xnm transpose. Similarly, the theta matrix is placed as a column, theta 1, theta 2, theta 3, without any transpose, all the theta matrix. And if you multiply these two matrices, x multiplied by theta, that is your this total matrix. In mathematical language, it is called low rank matrix factorization. So this matrix multiplication gives you the element wise different value of the Y matrix, where there are some unknowns, so unknowns can easily be obtained from this matrix. So there is other application of this approach, and that application is how to find the related video. So each product I will learn the feature vector xi. That means in case of movie, product is a movie. For certain movie, we learn the feature vector for that certain movie, which is xi in the order of n. And remember that x0 does not exist, so we have removed x0 from our calculation. So the features may be x1 can be romance, x2 can be action, x3 can be comedy, x4 can be any other characteristics of the movie. So these are called features. So if you learn all the features of all the movies, if someone watching a certain movie, and if you automatically can predict the other movie that is close to this movie that he was watching, so you can suggest that movie for him. So how to find out the related video or related movie? So how to find out the movie J related to movie I? So the technique is you determine the absolute value of xi minus xa. So movie J and I will be called similar if this value is very small. That means they are very similar. So if you want to find out the five most similar movies to movie I, find the five movies J with the smallest value of xi minus xj. So you take the smallest one, that is the very close to the movie I, then the next closest one, that is another similar movie, and so on in the order. You calculate the smallest value, and then you can say these are the movies which are similar movies to movie I. So this is another application of this particular recommender system, that you not only determine the unknown ratings, but also you can forecast the similarity of other movies or other product to a given product. Let us discuss about another application of recommender system for detecting the rating of certain movies. The particular user, have not rated any video. Either he have not watched or he didn't rate any movie. So how to predict the rating that user could have given? So let us see this picture. A new user, Ave, has not rated any movie, so the question mark indicates that. And as we have discussed about the collaborative filtering algorithm, this is the equation that we have to solve, minimize with respect to x1 and theta x and thetas. So if you want to proceed with this particular user, then number of features of this movie is considered as 2. So theta 5 will have a dimension of 2. The vector will have a dimension of 2. So these are the values. Since he has not rated any movie, so the term over there will be 0, because there will be no term with Rij equal to 1. So the theta will be determined by this term. As you know, this is a regularization term where lambda is the regularization factor, and this is summation of all the thetas. For theta 5, the equation can be written like this one. So as lambda is a high value, so these theta 1 and theta 2 will be very small value. So theta 1 and theta 2, as these are comes out to be 0, so x5 transpose multiplied by any x will give you 0, because since theta 5 is 0, so x1 doesn't matter. So ultimately it will end up with all the zeros. So this is actually meaningless, because if may not actually rate these all zeros. So this is useless, and this exercise is not fruitful. So how to then determine these unknown values in the y? And the technique is called mean normalization. In mean normalization, first of all, mean of all the movies, rating of movies, mean of the rating of the movies is determined first of all. For example, the second row, there are two movies. The movies two user has rated, so the mean is 2.5. Similarly, for the third row, two movies, two user has rated, so this is your C. In the last one, the four user has rated, so total divided by 4 is 1.25. So first step in the mean normalization is you form Y and then find the mean of each row or each movie. So then you subtract this mean value from the original value. So you are as if you are normalizing. So the values except the apes rating, that which no movies have been rated. So these will be the change in Y. So after subtracting the mean value from the original y, we get the modified y. And as usual, we learn theta j and xi for all the users and all the movies. Of course, the users who have rated the different score or different points in a movie. Of course, the user who have given the rating of the movie. So the user who have not given any rating, that will be automatically excluded. So after getting theta j and xa by our collaborative filtering algorithm, then we can find out the rating for user j on movie I. We can predict that value by this equation. Normally we do by this equation. Since we have subtracted the mean value, so we have to add the mean value now again to get the original value. So for user number 5, the Ave, the name of the user is Ave. So the theta 5 will comes out as a 0 0, as we explained in the previous slide. So if I apply this equation for theta 5, the equation will be like that. So since this term will be 0, so mu I will be the values for the different movies. So these are the rating of the movie, and this is reasonable because he has not rated any movie, so automatically we expect that the average of the others rating should be the rating for his choice. So these are the predicted rating for the user who have not rated any value. So this is one of the application, but there are several other application of this particular algorithm called collaborative filtering under this recommender system. Thanks.